So our goal is to get this linear equation into a form that we can use nicer. Okay? There are benefits from this on Desmos as well. Like we can put this into Desmos and get the x-intercept and y-intercept and graph the line. But it won't give us the table, and eventually we're going to want to say, like, at x equals 5, what's the output? At x equals 20, what's the output? And that's a great thing from the table. So we'll look at that in a little bit. But we are going to get y all by itself. The nice thing about this is that we're not, like, you don't need us to tell you anymore. We're solving for y. We're solving for x. We're solving for whatever, b or a. We're just solving for y every time. And once you do a couple, it's going to start to feel kind of repetitive, okay? And that's what we want. There are only a couple ways we can scramble these equations around with just an x, just a y, just a constant. So what am I going to move first? I'm reading this to myself and seeing 6y minus 2x. What am I going to move first? 2x, good. You're never going to break that couple of 2x up. You're always going to keep it together. So you're just looking to do that opposite sign. Here it was negative, I made it positive. Now is 2x a like term with 12? Heck no. If you made that 14x, now you're like totally sunk, so don't do that. I don't even line them up together like they should be like terms. I make sure that I make it easy for myself. 12 and 2x are not like terms because they don't have the same variable. They don't have the same exponent. All right, now how am I going to break this couple up? 6 and 1. Divide. And I'm going to divide everywhere. That's a big deal here. Because if you don't divide everywhere, you're going to get the wrong slope or the wrong y-intercept or maybe both. So my 6's cancel. 12 divided by 6 is 2. You can leave it as 2 over 6. How else could you write that? 1 over 3. And again, I'm gonna write it as 1 over 3. You could leave it as 2 over 6. You don't have to, but that's still the slope. It's just gonna be a little further apart. Now this is not in y equals mx plus b form. My b's in front. So I'm going to switch the order because again, what I want it to look like is this. So I'm just going to flip that around. Y equals x, take any signs with it. It's a positive 1/3 x plus 2. And that is my line that I wanted. Now we can graph. The worst thing you can do on these is go up here and be like, oh, the y-intercept is 12 and the slope is negative 2. That is not even close to what we've got going on here. Okay? So, we don't have it on this worksheet, but what I would do if I were you every time is make myself a little. What is M and what is B? My slope is 1/3. My b, I'm going to write it as 0, 2. Again, just like yesterday, you can write it as 2. What does that tell us? That b is our start. And the m is our pattern. So where are we starting? Over 0 up 2. What's our pattern? What does the 1/3 give us? Up 1 over 3. So remember, if it's negative, we're going to go down. If it's positive, we're going to go up. We're always going to run to the right of 1 over 3. 1 over 3. And then we're going to go down 1 and left 3 to finish it out. Again, you're going to fill in all those dots. So now is when I'm going to show you how to check your work. And for some of you, it's like, if this solving stuff is just not happening today, go through and practice with Desmos and get the graphs down. And then if you have extra time, come back and try to solve for y. So if you're like, yeah, I was not like this off last unit, I'm still lost. Okay, do this first. And here's how you're going to do that. I'm going to pull up Desmos. I can't believe I don't have it up yet. And I'm not going to put in my new line. I'm going to put in that original line, that original equation that was 6y minus 2x equals 12. 6y minus 2x equals 12. And what am I going to check? I'm going to check those two dots that are our new best friends, right? This guy, the y-intercept. I remember putting the y-intercept at 2. The x-intercept, you always get those 2 points. No matter what, you always get those 2 points. So my y-intercept is 2, my x-intercept is negative 6. And you could even find the slope here. I think it's easiest to count here. Well, here I see up 1 over 3 or up 2 over 6. So, like I said, I'm trying to kind of meet everybody where you are. If solving for y is not working for you, use Desmos to get that graph going. But what Desmos is going to show you are these 2 points. And then if you should be able to say, okay, that's up to 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. That was that slope that we got out of the equation anyway. We want you to be able to solve for y. It's going to be part of the unit test. But if you need to back it up for a second and just graph, well, we can work with that. What the priority today is get some graphs done. Okay? All right. Ooh, I like this one. It's going to be a really quick solve for y. We can do it in one step, but we have to do it carefully. How are we going to get rid of that divide by 2? Well, the 2 is in the bottom. So what are we going to do with it? Multiply, right? That's how we undo divide. I'm sorry, I thought I heard minus, and maybe I heard times instead of minus, and then I looked at you like you were crazy. Okay. So when I multiply by 2 there, which one do I multiply by 2? X or negative 1? Both, yeah. Just like over here, we did divide, divide, divide. If we are multiplying to the other side and we have more than one term, we have to multiply, multiply. So it's nice, we can get this into a nice form and just make sure 2x minus 2 times 1 is 2. Awesome. There's our y equals mx plus b. Slope here is 2. I'm going to write it as 2 over 1. Whenever we have a whole number, we can write it over 1. Our y-intercept is negative 2. So that's our start. And slope gives us our pattern. The little extra directions I'm writing down I think are really helpful. If you write it, you will be more like you're just helping your brain process that in a different way. Okay, so I'm going to start at negative 2. Rise over run, I'm going to go up to right 1. And those are the 2 points right there that we just plotted that Desmos is going to give you as well. So if you're working ahead and throwing that into Desmos to check, that's awesome. And to finish it out, we're going to go down to left 1. I'm going to try to make a nice line. So you just have to be really careful when you're solving or really careful when you're checking your work. One of those two. Again, I'm going to put that original equation into Desmos. Y over 2 equals x minus 1. We talked about it yesterday, but remember when you put divide by into Desmos, it's going to look like a fraction. And then to get out of it, you either have to hit over or just like touch there. Okay, equals x minus 1. And there are the 2 points that we could check. Those are the first 2 points. So again, you can get those first. Here's the thing that solving for y gives you. If I go here and go to this, I don't really, the only option I have with this equation in this form is to copy it or get rid of it. Watch what happens when I have y all by itself. 2x minus 2. Once I have y equals mx plus b, it'll let me do a table, and I can get any ordered pair on that line. So y equals is really powerful in Desmos, but it'll give you the graph without it. Now I can say, like, what is my output at negative 200? Oh, it's negative 402. And I don't have to touch that equation to get that. It's nice to have y all by itself, but you can get the graph without it. The other thing it does when you pull up that table is it gives you any ordered pair that's in that table as a clickable point, which is kind of nice. I like to click points. Okay. You okay? Am I talking you into liking Desmos yet? I feel like a salesperson. This is when Desmos became a thing for us, Mr. Schaefer felt like a salesperson. He was like, now we all feel like that. Okay. This is the form that you'll most likely see, that you'll see most often. We tried to switch it up just so it doesn't get boring for you. But 2x plus 3y equals 6, this is like standard form of a line. That's why you see it the most often. How am I going to move the 2x to serve? Absolutely. If it helps you to put a positive in front of there, so that you can think, okay, I'm undoing it, I'm going to subtract, that's lovely. You can actually do that. Again, it's not like terms with the 6, so I'm not going to put it anywhere close to the 6. I don't want to think that I need to do something differently with that. I'm going to bring down the 3y. Question, are you guys okay with this if I flip the order right now and put the 2x in front?
No.
Is that
No.
You don't know about that? Okay. I'm okay with not being okay with that right now. I'll just copy it. Are we okay with that? Thank you. Now, Sarah said divide.
Yes.
My girl. 6 divided by 3 is 2. 2/3 does not give us a pretty number. Now, if you weren't okay with flipping the order a minute ago, we've got to flip the order now. Okay? So I'm going to rewrite it. And I don't care when you do it. Now, what? Positive or negative 2?
Negative.
There's no negative in front of it. That's why I asked, because that's a tricky thing. So when you switch the order, just make sure you keep the signs with it. No sign is positive, right? Negative is negative. Okay. So our slope is the number in front of x, not the x with it. You guys did a really good job on your practice yesterday, not including that x.
So it's a negative, doesn't it go like...
Yeah. So if it's a negative, so here's our start, and here's our pattern. Sorry, that looks like pattern. So we're going to start at 2, and then negative slope means we have a downhill line. So, well, I'm always going to write that negative with the top number, and that's going to tell me down, but we're always going to run right. And if you do that, you're negative slope. So down to right 3. If you're not doing all the little points right now, check it in Desmos to make sure it's right so you don't have to erase later. So let's do that. I'm going to put 2x plus 3y equals 6 into Desmos. And make sure I have a point at 2 and a point at 3, right? That's where we had our points. Cool. So now I can be pretty confident and keep going. Down to right 3, down to right 3. We're going to keep that pattern going this way. Remember, you know something's gone wrong if you have a curve. You know something's gone wrong if you have a V. We'll do curves. You'll do absolute value as a V. You'll do that at some point. All right, one more. Let's have those pretty dots and that pretty line going on. I like it. Good. Okay, the only other way that I can think to give you an equation of a line is like this. This is actually point slope form. This is what we're going to do on Thursday. We're going to make point slope happen. Today we're just going to work with point slope. So when you see parentheses, what do you think you need to do? Parentheses absolutely mean distribute. So I'm going to leave the y minus 4 over here to hang out. I'm going to multiply that 1/2 in. 1/2 times x. 1/2, what's half of 6? 3. Half of 6 is 3. And then we need to move this, we don't have y by itself yet. I'm going to move the 4 over by adding it. Now when we add, we just need to find that like term. So I'm going to put it right under the 3 because it is a like term with the 3. Yeah, I love point slope, and it's really useful. So, slope. Y-intercept. Starts. Pattern. If you're writing start and pattern every time, it's going to pay off for you later because we are going to, it should be uphill. We're going to take word problems and write equations from the end in like a month or so, and start and pattern is going to be the way we get from this. Okay, so our pattern, once we start at 7, is up 1, right 2. Just double check, if you have a positive slope, you should have an uphill line. If you have a negative slope, you should have a downhill line. That really helps me check my work. So start at 7, and then our directions are up 1, right 2. This one's going to be a little tougher to see in Desmos just because the x-intercept was off our graph. It was plus 6, right? But here's what you can look at. There's our y-intercept, and then I can count, I see up 1 over 2, up 1 over 2, or up 2 over 4. So that's a great double check. The other thing you can do is put in that equation you count and make sure they're right on top of